Good morning and good afternoon. Welcome to the Power Hour webinar series, the program designed for our engineering partners like you. The program will offer concise technical presentations on topics pertaining to off-site power system design and specifications. It's meant to keep you updated on products, technologies, codes, standards, and developments, and the topics most relevant to your jobs and projects you're working on. You're going to be able to interact directly with the Cummins presenters throughout using the Q&A session in the live WebEx. So either it will be at the top of your WebEx session or on the right-hand side, and we'll be leaving sufficient time at the end to address as many questions as possible within the hour. These webinars are recorded and archived, so if you miss one or you have a colleague that missed one, visit our on-demand webinar series center, and we'll be giving you that information at the end, and look for additional topics of interest. You'll also be earning one professional development hour issued by Cummins upon your completion of the webinar. My name is Tom Bakritsis. I'm the Global Sales Training Manager for Cummins. Our presenter today is Mike Stanford. He's a Technical Marketing Specialist for Cummins. Our topic today is specifying generator set testing for reliable power systems. And with that, I'll turn it over to Mike.
Great. Thanks for the introduction, Tom. And once again, welcome to today's Power Hour. I'm going to be covering a great topic, I think a very important topic today, focusing on testing requirements and really how to specify them for generator sets in order to drive towards a power system that is more reliable. Now, I'm going to be talking a lot about different code requirements today. In particular, I'm going to be talking and referencing NFPA 110 throughout this course. And it is important to note that the information that you're seeing represents Cummins' interpretation of NFPA 110. However, it is always important that when working with code requirements that you're always referencing and working with the local authority having jurisdiction for their formal interpretation. But with that out of the way, let's go ahead and talk a little bit more about the course. As you saw with the course in the brief introduction we've given so far, there's going to be a few key points that we're going to cover. We're going to talk about generator set testing guidelines and focus a lot on best practices. What are the things that you should expect to see from a generator set manufacturer? We're also going to talk about the 4 key steps of the product testing process. We're going to spend the bulk of this course walking through that testing process. We're also going to talk about appropriate methods of specifying generator set testing strategies. And then we'll also highlight throughout the course the impact that these testing strategies have on power system reliability, which will be a major focus of the course. So with that, let's go ahead and get started here. First and foremost, we're going to talk about the product testing process. And I'll give you a brief overview before we get too far into the course. It's important to specify testing requirements, and there's a few key reasons why we do recommend that you clearly define testing requirements in your specifications. First and foremost, there is not in existence a single performance test standard for generator sets. And what I mean is there are many codes and standards organizations today that develop and publish and adopt generator set testing guidelines. However, sometimes they're incomplete or lacking in different areas, and so there's not a standardized testing process across generator set manufacturers that adequately covers all the key aspects of the product testing process. Testing throughout the life of a product is what ensures adequate product performance at all stages of assembly installation. And so what you're seeing on that right-hand side there are what we see as the 4 key steps of the product testing process. So we're going to start by talking about prototype testing, which is testing conducted by the generator set manufacturer. We'll move into factory testing, then site testing, and wrap up ultimately with maintenance testing. You'll see throughout this course how testing at each of these 4 phases is critical to driving towards a more reliable power system. So first and foremost, let's talk a little about prototype testing. Prototype testing is a key part, very important to the success and the reliability of a power system, that prototype testing be conducted on all the components within it, but we're going to focus here on the generator set aspect. And so the first point here being that prototype testing works to validate a complete product's operating characteristics and limitations as well as its ability to withstand what we refer to as normally occurring abnormal events. And what I mean by this are things that generally, you wouldn't expect to see some of these events, but they do happen. These are things like a short circuit. That's obviously not something that is normal in the operation of the generator set, but certainly does happen. So this is what we would refer to as a normally occurring abnormal event. Prototype testing will often include potentially destructive testing, and that's key to note because sometimes we do see prototype testing, we do see testing requirements specified for a non-prototype for the product that you or your client is purchasing. And when that testing is potentially destructive, we often recommend leaving that to the prototype product and not conducting that potentially destructive testing on your actual product. I'll talk more about potentially destructive testing here in just a short bit. Prototype testing also works to define installation design parameters. And what I mean by this is that prototype testing is what helps the manufacturer to establish the operating parameters of the particular product. It also provides a realistic baseline for performance expectations. And again, here by that what I mean is that some testing will help us to establish a range of acceptable performance limitations that should be seen with a product that's configured for a specific project. Lastly, and you'll hear me say this a few times, prototype testing is just one part of the product life cycle, the product testing life cycle, and it is critical to the reliability of the power system. So I'm going to talk here, again, first a little bit about NFPA 110 because most of you may have had the thought when I said there's no one standard that specifies testing requirements for generator sets. Some of you may have thought, well, how about NFPA 110? And NFPA 110 does do a pretty great job, actually, of listing, and I'll just stop at listing some of the requirements for prototype testing. However, although NFPA 110 does require the generator set manufacturer certify compliance to certain testing requirements, each manufacturer is free to decide what testing is actually necessary for their product. And so what that means as a result of that is actual testing practices amongst manufacturers varies dramatically. And so although NFPA 110 might say that short circuit testing is a requirement for a prototype test, different manufacturers may conduct that same testing in different ways. And so ultimately it is up to you, the designer, to understand what is realistic and what should be required, and to evaluate the ability of a specific supplier or any supplier to actually meet those objectives as outlined in NFPA 110. And what you're looking at here on the right-hand side is an example of a document that some manufacturers do provide, or some generator set manufacturers do provide, that provides a high-level overview of the prototype testing that has been conducted on a particular unit or a particular configuration of a product. This can be very helpful when trying to understand the prototype testing that has been conducted on a product, and I always recommend that you request this type of document or something similar to it in your submittals. This should be a requirement from a generator set manufacturer. The other thing I'll note here, and this goes along very closely with the comment I made earlier, in that I stated that each manufacturer is able to decide what is required for their particular testing procedures for their particular product. Not all manufacturers are the same, and there's a couple things you can look at here as an example. One, on this left-hand side, what you're looking at is a compliance document, a certificate of compliance with a quality standard. In particular, this is ISO 9001, which mandates quality standards or level quality practices of a manufacturer. This is something I always recommend that you require from generator set vendors to supply with their submittal. Every generator set manufacturer in North America should be able to provide you with this document certifying their compliance with this particular quality standard. That's kind of a process standpoint, but what you don't see in a certificate like this is the actual testing facilities, the actual capabilities that a manufacturer may have. And the capability of a manufacturer highly impacts the quality and the accuracy of the data that's provided with this prototype testing. And so on the right side, what you're seeing is an example of a state-of-the-art facility capable of delivering the highest quality sound testing data in this case. And I'll talk about that here more in just a little bit. So before I go too much further into prototype testing, one of the key pieces to note, and this is again out of NFPA 110, this is section 5.2.2, it specifically requires that for the prototype test, the product shall be tested with all of the parasitic load-inducing accessories, all the accessories that may impact the power of the product. This is important because not all manufacturers necessarily adhere to this, and in some cases that's okay, but in many cases it's not, and it's something at the very least you need to be aware of. On the right-hand side, what you're seeing is a description of the different ratings that the product complies with. And one of the key ones there is actually ISO 8528, which you see highlighted in each of those 4 rating definitions. It's important to note that ISO 8528 compliance because ISO 8528 specifically calls out prototype testing or ratings that are indicative or are inclusive of all of these parasitic loads. What you don't want to see from a generator set manufacturer in their rating definition is a sentence that says something like product rating dependent on configuration. What that tells you is that the product may not have been tested with all the appropriate accessories to yield a prototype that can actually deliver results or testing results that measure up to what you would expect to see in the field. And so again, this is where I'd recommend that in your specifications, you require vendors to include submittal information that is representative of the final configured product and is inclusive, and the data, the performance data is inclusive of all accessories that may impact the power output or product performance. The next thing I'll note here, and this is actually what's called out by NFPA 110, it lists all these 7 items, and it says these are the tests, these are the prototype testing requirements that NFPA 110 has for a generator set manufacturer. The concern I have here that I brought up earlier is that this is the level of detail that NFPA 110 provides. It does not go into significantly further detail than what you see here. And so that very first one, when you see short circuit testing, it should be tested for the ability to withstand short circuits. What does that tell you? What leniency does that allow the generator set manufacturer? How confident are you that each manufacturer is testing to the same level of performance? And so generally what you'll see from all manufacturers in North America is in some sort of indicator of compliance with this standard, and that word is key, compliance. And so what that means is that the majority of the manufacturers in North America, as far as I'm aware, are willing to commit to and say that they comply with these requirements as stated in NFPA 110. What I'm going to move into and talk about next are the things that aren't specifically called out here and why they're important and why you should be calling them out in your specifications above and beyond what's listed here in NFPA 110. So a few key components that I'll talk about. One, endurance and durability. All the products that are assembled by a generator set manufacturer have typically been tested by their respective manufacturers. However, not all generator set manufacturers test the product as a complete assembled unit, and it's critical that this be done. It's important to ensure that the product that you're reviewing has been tested as a complete assembly. Vibration is another key piece here. There are various standards that provide recommendations or guidelines for vibration testing, but at the end of the day, an indicator of compliance from the generator set manufacturer that has stated that it has conducted vibration testing to ensure the prolonged life of the product is key. There are various standards. ISO 8528 does have some vibration guidelines. However, it is important to note that they are just guidelines, and different vendors may use different strategies to verify vibration performance. Torsional compatibility is another key piece here. And what we're talking about with torsional compatibility is really the compatibility of all the rotating equipment, the engine, alternator, the coupling, and the radiator fan in particular. These are key because, again, a lot of the time these components are verified or validated by their individual manufacturer, but they may not necessarily have been tested together. This is the difference, key takeaway here. This is the big difference between a generator set assembler and a generator set manufacturer. A manufacturer will be conducting this torsional compatibility analysis to ensure the product is fully developed as a complete assembly, whereas an assembler may be just taking these components, piecing them together, and shipping them out the door. The last one I'll talk about here, and this is one of our potentially destructive tests, is seismic compliance. You see this in various flavors that are needed based on the regions. This may be IBC or OSHPD, CSA, IEEE. What you should see from any generator set vendor is a document that looks like the sample on the right-hand side of the screen that indicates compliance with the particular standard to the level of performance that you need. Moving into some additional prototype testing expectations, short circuit capability is one that is clearly called out by ANFPA 110. However, again, this is one where you should ask some additional questions to understand the true performance capability of the generator set manufacturer as it relates to the short circuit testing that's been conducted on that product, in addition to considering the inherent short circuit protection that may be included in the generator set manufacturer's controls package. Transient performance is another key piece of prototype testing, as this really helps to establish a baseline of performance for the product once a unique configuration is assembled for your particular project and for when it's installed on site. Sound performance is another key piece here, where we see sound testing being conducted as a prototype. However, it also needs to be tested later on at the site in order to validate performance. Sound testing is often challenging for generator set manufacturers, especially for high horsepower products, because of the challenges associated with sound testing. What you're seeing there on the right picture and in the picture early on, that facility is specifically designed to absorb all of the sound that is transmitted or that is propagated through the structure from the generator set. A manufacturer that is using an engine test cell or a small generator set test cell to conduct sound testing may not be able to deliver quality sound data during their prototype test, which may result in a product that once installed on site may not meet your local requirements for sound, and that can be obviously a concern or a challenge that you or the owner has to manage. The last one I'll talk about here is on the cooling and ventilation side. This is another key piece that we see kind of drives the difference between an assembler and a manufacturer, and that's validation of the cooling system. Not only should the cooling system be validated by the generator set manufacturer for the air temperature and airflow and restriction conditions, but you'll see that some manufacturers are actually capable of testing their cooling systems at temperature. And so when you see a manufacturer who provides a cooling system that is rated for 104 degrees Fahrenheit, ask whether or not that cooling system was actually tested at 104 degrees Fahrenheit, or if it was tested at whatever temperature happened to be available in the test cell that day, and that data was extrapolated. So again, driving towards what you should be looking for from prototype testing is not just an indicator of compliance with NFPA 110, but you should be looking for additional testing detail, additional data or data sheets that the manufacturer can provide that indicate the additional prototype tests that have been conducted on that particular product. So with that, we are going to move quickly into a concept check here, and I'm going to go ahead and read through this, and we'll give you an opportunity to respond. With regards to generator set prototype testing, which one of the following sentences is true? All generator set manufacturers conduct the same type and depth of prototype tests. Additional prototype testing beyond NFPA 110 is never needed for a generator set product. Generator set prototype testing will include potentially destructive tests, or prototype testing is not needed if a rigorous site testing plan is implemented.
All right, folks, go ahead and send in your answers. It's one of the following, A, B, C, or D. So go ahead and send that in through your Q&A box or your chat box, and we'll be looking at those and letting you know what's correct.
All right, I see we have some answers coming through.
Yeah, we are getting a lot of C's.
Get a lot of C's in here.
There's a couple of...
Okay, great. Great comments. Thank you for your participation. And so clearly, in this case, the only true statement here is that generative prototype testing will include potentially destructive tests. In some cases, or I should say, we will talk about site testing later on, and one of the things that you'll see as I talk about site testing as well as factory testing and maintenance is that they all rely on prototype testing to form the basis of performance. And so a rigorous site testing plan can never be a replacement for solid prototype testing. Great. Once again, thank you for your participation. With that, we're going to go ahead and move into factory testing. So factory testing, the big difference between prototype testing and these next three parts of the product testing lifecycle is that prototype testing is conducted on a prototype, whereas factory testing, site testing, and maintenance testing are all conducted on the actual product that is going to be installed on site. So factory testing, first of all, validates the assembly of the generator set in the unique configuration that you are going to receive it, or your client is going to receive it in. Factory testing relies on prototype testing to have established a baseline performance criterion. So a factory test is going to look back to prototype testing to ensure the product is performing as expected. Factory testing also establishes a baseline performance criteria for the subsequent site testing. So site testing, when conducted, is going to look back to our factory testing to ensure it's performing as expected. Another key point here, factory testing relies on a qualified manufacturer who is capable of conducting the test, has adequate facilities, and the personnel to actually conduct the testing. And again, factory testing is just one part of the product life cycle, the product testing life cycle, and it's critical to the reliability of the power system. So some things that you'll see here for factory testing. One, first and foremost, you should be able to at least request documentation of the product being tested, and that should be down to the model and serial number of the product that you're being tested. This should be easy to request from any generator set manufacturer. You'll also see standardized tests from the generator set manufacturer. This could include startup testing, steady state stability, and full load pickup. These are fairly straightforward, and these are something that the generator set manufacturer is going to conduct in order to verify the performance in the unique configuration of the product. Again, we always recommend that you require vendors to provide a certificate or a letter or statement indicating compliance with the factory testing that you have specified. There are lots of options for optional testing. Many generator set manufacturers, I'd say all or most, if not all, generator set manufacturers are willing to go above and beyond to meet your specific factory and site testing requirements. It's just important to note that if you have those specific requirements that you want to see met, that you specify those clearly. So things like including additional documentation such as a strip chart to demonstrate and to record the performance of the product as it goes through its site testing. Extended run testing is also quite common, especially for larger projects, and this is where you may run a product for 2 or more hours in a manufacturer's facility. Demonstration of the safety shutdowns is also a common test. However, it's important to note that most generator set manufacturers simulate the safety shutdowns, and what I mean by that is if this shutdown that is requested to be demonstrated is excessive oil pressure or low oil pressure, the manufacturer isn't going to cut an oil pressure line on their live product to demonstrate that the safety shutdown works as intended. Instead, what's going to happen is a control system is going to be used to simulate a loss of oil pressure to the generator set control, where you will see it appropriately shut down as needed by the generator set manufacturer. Witness testing is also a key piece that we often see with factory testing. And witness testing is really, this is your option to be on site for all or as much of the factory testing as you would like. And again, this is highly recommended for large projects or complex projects. With that, I'm going to move out of factory testing. I know it was a relatively short section, and I'm going to move into talking about site testing. And when I'm talking about site testing, what I mean is the product has arrived at the site where it is going to be installed, and these are the kind of the last few checks before the product is kind of officially commissioned. So the site testing isn't just validating the generator set, it's validating its ability to perform as installed. And so on one hand, it's a test of the generator set, but it's also a test of its integration with the facility, so it's testing much more than just the generator set. Site testing relies on factory testing having been conducted in order to look back at a set of baseline performance criteria. This is also establishing that's a similar baseline performance criteria for subsequent maintenance testing that will be conducted later on down the line. Site testing relies on qualified technicians to conduct the testing adequately. And of course, I'll repeat it again, site testing is just one of the 4 pieces of the product testing life cycle. So let's look at a couple different recommendations or guidelines for site testing. What you're seeing on the right-hand side there is taken directly out of NFPA 110, and what I'll say about this is, similar to prototype testing, there's a lot of information requested or required by NFPA 110, but I'm going to talk about some things that aren't necessarily called out, or I'll share a bit more detail about some of these specific tests. A cold start test is fairly common, and don't let the term cold start worry you too much. The intent here is to test the capability of the generator set to start as if it was called on an emergency situation and meet any start time requirements that you may have. And so this is really testing the starting system and any starting aids, as well as the power system scheme, and ensuring the system is meeting your reliability goals. Full load acceptance and steady state operation is also fairly common. So we'll see maybe different sets of transient tests, and then full load pickup, and then we'll look at the steady state operation of the product. It is important to note here, this is a question that we get fairly frequently, is regarding the power factor that the product should be tested on for on-site testing. And the concern here stems from the fact that typically on-site testing, especially commissioning, we see load banks rented instead of using permanently installed load banks. And for a rented load bank, a resistive load bank can, in many cases, be less expensive than a reactive load bank. And so generally what most manufacturers would recommend is that testing with a purely resistive load bank at a 1.0 power factor is acceptable for on-site testing. Now, if you would like to see testing at 0.8 power factor on site, absolutely, go ahead and specify that. Just be aware that there may be additional cost implications with that type of testing. Some other on-site testing expectations or types that we see include things like sound testing. And sound testing is often verified on-site if there is a local requirement from some local authority. And the key here kind of takes us back to our prototype testing point that we made earlier, in that the ability of a generator set manufacturer to promise or guarantee that they're going to meet your on-site requirements relies heavily on that prototype testing and its quality. And so a site test is only going to be there to verify the performance of the product as it is installed. It's also going to be done in order to account for things that the generator set manufacturer couldn't account for during prototype testing, like additional walls or acoustical barriers that are installed on site. Emissions is another area that we're seeing more and more on-site testing with commissioning of products. This is typically mandated by some local authority or air board. Again, just be aware that this may be a requirement in your particular facility. Definitely consult with the equipment manufacturer and any other needed vendors, such as test laboratories that may be needed to conduct this testing. Third parties are sometimes brought in additionally for on-site testing and commissioning in order to validate or be there as kind of a neutral party to verify the product performance. Now, typically we don't see these on small projects, but large projects with complex systems, bringing in a third party to validate the entire power system performance may be a recommendation. Now, it is important to note that if this is going to be a requirement, that this be clearly communicated to all vendors involved, as this type of testing and verification can have extensive time requirements as well as cost associated with it. Okay, real quick concept check here on the last two topics. Factory testing validates the blank of the generator set, while site testing validates the generator set's ability to operate blank. And that's A is in installation and as configured, B is assembled configuration and as installed, C is prototype and when properly maintained, and D is performance and in an emergency.
All right, go ahead and send your answers in. We'll review them real quick. We've got a bunch of them coming in right now, Mike. Lots of
and a few answers coming through.
B's and D's, an A. They're kind of all over the place.
So a little, getting a lot of answers. It looks like mostly B's, but a couple of answers as well. So let's talk through each of these. So first of all, we'll go in and say the answer here in this case is B, and the reason for that is we talked about the fact that factory testing validates the assembled configuration of the product, right? Because prototype testing is typically conducted it may be conducted on a representative model that's used for those prototype testing purposes, whereas factory testing is validating the unique configuration that is being sold and installed in your particular project. Site testing is there to validate the generator set's ability to operate as it is installed on site. And I talked about the fact that site testing isn't testing just the generator set, it's also testing the way it has been integrated into the entire power system in the facility. And so in this case, we would definitely say that B is the correct answer. All right, thank you again for your participation. We're going to move into the last portion here where we're going to talk about maintenance testing. And it's important to note that in no way, shape, or form can the maintenance of a product ever increase the reliability of a power system. It can only ever maintain the inherent reliability derived from the research, the specification, and the products that have been installed into that power system. And so maintenance testing is typically conducted in order to help address common failure modes of both the component and the complete power system through routine inspection and service. Maintenance testing relies on site testing to have established that baseline performance criteria. And so maintenance testing has to have something to look back at in order to understand whether or not there's a concern or there's an issue. And so that site testing, prototype testing, and factory testing all need to have been done to empower maintenance testing to do what it needs to do. Maintenance testing also establishes a baseline for the product throughout its entire life after commissioning. Maintenance testing does rely on qualified technicians to conduct the work adequately. And of course, it's one part of the product testing life cycle. So a few keynotes here. This is pulled directly out of NFPA 110 in discussion of routine maintenance and operational testing. It says the routine maintenance and operational testing program shall be based on all of the following. And I'd like to point out that the first two items called out by NFPA 110 are the manufacturer's recommendation, that's the product manufacturer's recommendation, and the instruction manuals provided by the generator or the component manufacturer. This is a key point because many times what we see are generator manufacturers have qualified and trained technicians that come on site and support the commissioning and installation of the product, and after that, if those technicians are not the ones servicing it, it's maybe technicians, owner technicians or something, that may not be following the same maintenance testing requirements, which clearly does not meet the expectations for an NFPA 110. And so we generally like to ensure that products are being maintained by factory-trained service engineers and that the those service engineers have access to all the replacement parts that are needed in order to maintain the reliability of that product so that it can work effectively in that complete power system. Some comments here about testing with load, another question that we get quite often about especially diesel generator sets. And so NFPA 110 very clearly calls out how you should be testing a product on a regular basis. It says, shall be exercised at least monthly, that's once a month, for a minimum of 30 minutes using one of the following methods. And there's two methods recommended here. The first and foremost, and typically the most preferred by engine and generator manufacturers, is to load the generator set until the engine exhaust temperature meets a level as recommended by the manufacturer. Now, as you can imagine, this has some kind of, you have to do a little bit more work to accomplish this. So NFPA 110 offers another recommendation, that's that it can be operated at not less than 30% of the standby nameplate rating. And that's typically what we see most often done. Now, so this is once a month, 30 minutes, 30% load. NFPA 110 goes on to say, if that is not able to be done, here's some other recommendations. And it says if you can't do that, it shall be exercised annually, once a year, at not less than 50% for 30 minutes, and at not less than 75% for 1 continuous hour. Again, and I would like to say that most manufacturers within North America are consistent with these testing requirements. However, I would always recommend you yield to the generator manufacturer testing requirements. Those requirements are put in place in order to help you drive your system to be more reliable, and deviating from that may drive towards a less reliable power system. Our recommendation would always be to specify a right-sized, permanently installed load bank to allow for proper testing. Otherwise, you are bringing in load banks on a rental basis, which can actually be more costly than a permanently installed product. I'll also talk here briefly about fuel testing. This is another very important testing requirement that we see on site and during the maintenance program. NFPA 110, as of today, has very little language about this. It simply states that a fuel quality test shall be performed at least annually using appropriate ASTM standards. Most manufacturers would agree with at least annually being sufficient. However, depending on the size of your fuel system on site, additional testing, whether that's twice a year or even quarterly, may be appropriate. We see this especially for larger facilities. However, the other key thing to keep in mind here is the capability of that testing and what that testing is telling you. And so actually there's a temporary interim amendment it's in the works right now that is going to expand the requirements for fuel quality testing in 2019, and I included just a few details from that TIA, and it goes on into much greater detail. In fact, it's actually a couple pages long as opposed to the standing requirement today. So this is just something to be aware of and look forward to as we move towards the adoption of that TIA. The starting system is also one of the key failure modes, or the key reasons for a fail to start on a generator set. So this is clearly called out by NFPA 110. Really the requirement here is to test and check and inspect those batteries to make sure that they are in good health and are being replaced when appropriate. We do always recommend that you yield to the generator manufacturer's expectations or guidelines for battery sizing, but also look to the generator manufacturer to provide a recommendation for the battery charger, in not only its amperage or its ampacity rating, but also in its features and functions. That will help to maintain the batteries at their kind of in their prime. One of the last things I'll note here comes back to maintenance records and requirements. This is also clearly called out in NFPA 110. You can see a lot of the details that are required and mandated, down to things like data maintenance, service personnel, everything that's being done as part of those maintenance records. This is an opportunity to look at your gear your gear, or your generator set vendor to find out if there are options available from that vendor to automate some of this for you. More than likely, this testing or this maintenance is fairly routine, and any ability to automate this or have this easier to handle, manage, and produce upon request can help to lessen the load on the facility owners and operators. And I'm going to go ahead and wrap up here with just one quick concept check. Per NFPA 110, 8.1.1, the routine maintenance and operational testing program shall be based on which of the following: the manufacturer's recommendation, the instruction manuals, the minimum requirements of this chapter, or the authority having jurisdiction, or all of the above.
We had answers coming in before you even started, Mike, so we've got a lot of E's coming in.
Great.
Lots of E's.
Wonderful. And so yes, I'll go ahead and move on here. Yes, the answer is very clearly E in this case. It's directly out of the slide. And however, although I took the time to emphasize the fact that the manufacturer's recommendations and the instruction manuals are critical to the reliability of the power system, NFPA 110 does call out all 4 of these as the requirements for routine maintenance and operational testing. It is important to note, especially with any local authority having jurisdiction, that there may be testing requirements that go above and beyond. We actually recently conducted a power hour on this topic as it applied to the healthcare market. You may want to reference that if you have interest in that particular market. But just be aware that there may be additional testing requirements from the local AHJ. So with that, I'm going to go ahead and wrap up today's course, and I want to leave you with a few questions to ask yourself when you're reviewing your specification and when you're working with vendors on specifying those testing requirements. Try to determine and ask the vendor for documentation so that you can better understand the prototype testing that has been conducted on that particular product that you're specifying. Again, not all vendors are conducting prototype testing in the same way and at the same depth, and it's important to ensure for your power system that you're able to understand and decipher between the testing that has been conducted from different manufacturers. Try to look for more details, ask for certification of compliance, or ask for compliance with your testing requirements that are also conducted at the factory. And also look for the opportunity to engage in witness testing. It really gives you an opportunity for a hands-on touch with the product before it ever leaves the manufacturer's facility. Oftentimes, issues with especially generator sets issues are typically found within the first couple hours of operation of the product, and so an extended run on a larger project may help you to catch some of these issues ahead of time. Ensure that the manufacturer is able to demonstrate product performance through both prototype and factory testing. And again, ask for that documentation. Ask for a certified test report or similar as proof of the product's performance. Above and beyond prototype testing and factory testing, ensure that, one, you're aware of the site testing requirements, especially if there are site testing requirements specified by a local authority, and ensure those are clearly communicated to all generator set vendors or all product vendors so that they can ensure that that product, when it arrives on site, will meet those testing guidelines. Ensure that when you're reviewing your power system maintenance program, that the program is all-encompassing and meets the expectation of not only NFPA 110, but also any expectations that you may have, the owner may have, or the local authority may have. And ultimately, at the end of the day, what we're trying to work towards is driving towards a more reliable power system. And so look at the testing requirements that you have within your specification and ask yourself, are those testing requirements that I've specified really driving towards that more reliable power system? And if they're not, certainly this course provides a strong basis for a potential addition to your existing specification. So I covered a lot of information here today. We talked about testing guidelines and commonly used best practices. We talked about the product testing process, all 4 steps, prototype testing, factory testing, site testing, and maintenance testing. We talked about various methods and requirements and suggestions for specifying generator set testing strategies, and we talked about the reliability benefits that these testing strategies may have. We do recommend that you have a definitive section within your specification that calls out these testing requirements, and we do recommend that you specify certification of compliance or some sort of compliance from the manufacturer that indicates that they are meeting your testing expectations. We'd like to recommend that you avoid unnecessary testing, and I picked on NETA here as an example. There are testing strategies that we see adopted sometimes that go kind of the far end of things, where we're seeing tests that are either potentially destructive or they're tests that have already been conducted by the manufacturer, and a repeat of them in the field or on site is only driving additional costs in the product. So be aware of unnecessary test requirements and ensure that you're providing only what's really critical to your particular project. So with that, I am going to go ahead and wrap up today's course.
Great. Thanks, Mike. Another great presentation. As always, good content, good information. We encourage everybody to send in their question and answers through the Q&A box in the WebEx session. You'll find it on the top side of the lower right-hand side. We've got some questions that came through about this content, the presentation. I'll be giving some more information, but we will be publishing a consolidated frequently asked question along with the presentation and webinar recording at powersuite.cummins.com. And here on this page, you can also find all your local Cummins contacts, whether they're in your region or a specific state. Go ahead and note who you need to connect with to get additional information. So, Mike, one of the first questions we have is, what's the definition of a prototype? Is the prototype testing only done at the development phase of a new genset before coming to market? Do we need Do we need to know when buying an existing off-the-shelf model?
Great question. Thank you. So typically, I'd say you're absolutely right. The prototype of a product is typically done during the development of a generator set. And so you'll see this with a product that is new to the market or a newly released product. So for example, what will happen in this case is the generator set manufacturer will test various configurations in a prototype scenario. This is not, so that's what we look at as a prototype, and that will typically include all of the major different configuration options of a particular product. And again, as I stated earlier in the presentation, this is really done to better understand the way the product is going to perform in those different configurations. Typically, when you're buying a quote, off-the-shelf model, the prototype testing has already been done, but this is where I said, you know, it is important to ask for documentation or certification of compliance with these prototype testing requirements, because I guess I'll say it this way, you don't want your project to be someone's prototype. Right? You want to ensure the manufacturer has done their appropriate prototype testing and you're receiving a vetted product from the manufacturer. And so there shouldn't be prototype testing should have already been conducted by the manufacturer.
Excellent. Before we move on to the next question, we're also going to be sending out a poll right now. We're always looking for improvements and ways we can make this program better and make it, more better for you guys and look for improvements. So go ahead and answer that in the meantime. So we'll move on to the next question. I saw the seismic vibration test video promo of Cummins and must admit that what I saw was impressive. So that's kind of a comment, but I think you can speak more to that.
Yeah, absolutely. It's a great comment, and I will be honest. If you go to YouTube right now, you can Google. I'd like to see you Google Cummins generator set seismic testing, but you will find seismic testing videos conducted from various different generator set manufacturers, and absolutely there is something incredibly impressive about seeing a 3.5 megawatt generator set up on a shaker table. It is something kind of amazing. And that is important to note. During the prototype testing process, these are the lengths that manufacturers go through in order to ensure the product that you're receiving at the end of the day will meet your expectations and will survive in the environment that you're putting it in.
All right, next question, Mike. Thank you. Can you describe cons and pros of 2HR versus 4HR full load testing?
Yeah, so the question's about 2-hour versus 4-hour full load testing, and realistically, especially if we're talking about site testing or even factory testing, like I said during the course here, was most generator sets, when installed on site, if there are going to be any issues with the commissioning process or the initial installation operation, it's going to be caught within, I'd say, the first 2 to 4 hours of operation of the product. And so for larger sites where we're talking, dozens of generator sets, 20, 40, 60 generator sets on site, it is fairly common to see a 2-hour, 4-hour, even an 8-hour full load test conducted. Now, we will often also, I shouldn't say often, we sometimes do see requirements for something like a 48-hour full load test on a standby generator set. If you were to look at, across North America, all of the standby generator sets in operation today, I'm willing to bet, I shouldn't bet, but I'm willing to guess, I'm willing to estimate that less than 1% of them have more than 50 hours at full load outside of testing. And what I'm saying by that is that's specifying a 48-hour full load test is similar to requiring a car dealer to run their car for 50,000 miles and then expect it to do another 50,000 miles without any sort of maintenance or testing of it. It's not really practical. And so it is important to note, specify those full load testing requirements as appropriate for the project that you're working on. But I don't always recommend those extensively long 48-hour, 72-hour full load tests of the products.
All right, great, thanks, Mike. What is the normal time run for factory tests with full load?
Great question, and this definitely does depend on the generator set manufacturer. I would say that most generator set manufacturers run at least 20 to 30 minutes at full load at the factory. And this is where, if you would like to see it run for, if you're confident, if you want 30 minutes, don't rely on what you think most generator set manufacturers do. Call out 30 minutes at full load in your specification and hold the generator set manufacturer to that. They should be able to provide some sort of indicator of compliance with your particular requirement.
All right, next question. Will you recommend to wire a genset, ATS, and switchgear together during the
factory acceptance test?
Yes, factory acceptance.
Yep. So, yeah, the question is about kind of installing or testing the entire power system within the manufacturer's facility as part of the factory acceptance test. And I'd say for the most part, most generator set manufacturers, many generator set manufacturers may not be able to accommodate a full system setup within their facility. The other thing to consider is that most generator set manufacturers are not the manufacturers of their own lines of transfer switches and switchgear, and so you may run into some issues there as well. So I'd say typically we do not see this sort of testing done. This is where site testing is critical. Site testing cannot be skipped because generally site testing is the first time you're going to have all of the products in the power system connected to one another and operating and testing their ability to operate. Now, there is a benefit here to working with a vendor that does provide the entire line of power systems equipment, because then you can at least be sure that that product does work well with each other. When you're looking at equipment vendor, or you're looking at various equipment vendors to satisfy the entire power system lineup at your facility, the challenge may be if those vendors are not communicating prior to commissioning, then you can imagine that commissioning may take a bit longer than expected in order to get everything tuned up.
Good. We have some great questions coming in. Next question. How do you figure the right size load bank?
Good question. I talked very briefly about this. sizing the right size load bank really comes down to a couple things, and the biggest one being, well, how are you going to test the product? And so if you're looking at meeting the bare minimum requirements from NFPA 110, which says 30% load, and again, I think most generator manufacturers would agree that 30% load is the minimum that we would like to see for regular testing. Well, in that case, it's as simple as taking potentially 30% of the generator set standby rating and going there. However, this limits you this limits you from doing anything outside of that standard testing. And so for larger projects where you want to be able to do things like annual full load testing, or you want to, or if you're required to do things like annual emissions testing, in that case, what you may need is a 100% sized load bank for your facility, at least based on one generator set. On the other hand, if you're looking at annual testing requirements as stipulated by the owner or some AHJ that require you to test the functionality of a segment of your power system, so maybe 2 generator sets on a single bus, you may need a load bank that's large enough to accommodate both of those generator sets. And so it really comes down to the requirements of the site. Those are going to drive sizing your load bank appropriately. But typically what we see, if anything, is a load bank size for 30% of the generator set's rating, and then rental load banks brought in as needed.
Good. Thank you. Next question, Mike. Upon load acceptance and rejection tests at the site, what positive negative frequency variations are acceptable?
Good question, and I'll give you the good engineering answer. It depends. So this what you're asking for is the frequency and or voltage variation for a specific product as it's installed in your specific location. This is where you should always be working with the vendors throughout the specification process to ensure that, one, you're specifying requirements that are attainable. That way you're able to get a solid number of vendors to respond to your specification, but also so that they can help you to clear up and define what those frequency and voltage deviations may be. Now, after that point, it's important that you're working with the different vendors, looking at prototype testing, looking at factory acceptance testing, looking at factory testing, looking at site testing, to identify whether or not that manufacturer is holding themselves to the requirements that they've helped you to work on in your specification. So again, it really goes back to it depends on the particular product. For example, it's common that large natural gas products may not have the same performance as a large diesel product. However, that is not always the case. In fact, there are many natural gas products on the market today that are capable of meeting diesel-like performance. And so we don't like to see specifications that are kind of including these requirements blindly. It is more important to work closely with the vendors to get a good basis for those requirements.
Awesome. Thanks for that response. Next question, Mike. See, does NFPA 110 specifically require the 100% single-step test?
Yeah, good question. So there are many places we see this 100% load requirement specified, and often we see this is often required from an owner standpoint or from a site standpoint regardless. I'd say this is conducted almost always with site testing as a requirement or as an acceptance requirement for a product on site. And again, as I mentioned in my previous comment about diesel and natural gas products, be aware of what different vendors are able to provide. It is not common across all manufacturers to have a complete line of products that can meet 100% load acceptance. Again, I'll use large natural gas products as an example. It is not all manufacturers can meet that 100% load step requirement. That doesn't mean it's not possible. So what I would say is work to understand what the requirements are for your facility, your project, and the products that vendors are able to provide.
Okay, thanks, Mike. We got time for one more question here. Also, is it let's see. Is there a difference of testing requirement for prime versus backup power gen sets?
Good question. And so really what we're talking about here is if we have a product that is intended to be operating around the clock. We have a product that's being installed in a remote mine, and it's going to be providing the sole source of power for the facility versus a product that is only serving as the backup power. And should there be different testing requirements for those types of generator sets? And I would say that most manufacturers who offer products intended for prime operation will be testing their products differently than a product that is intended only for a standby market. And one of the ones I'll pick on, a test that I'll pick on, for example, is a manufacturer who is offering a product intended only for a standby market may conduct fewer hours of endurance or durability testing, whereas if it's going to a prime market, it may be tested longer in order to ensure that it meets market expectations. That's what the manufacturer may be doing themselves, but as I stated before, every manufacturer is going to be doing something differently based on their expectations. If you have different expectations for a prime generator set versus a standby generator set, clearly define what those are in order to ensure the generator manufacturers are meeting your expectations.
Excellent. Thanks for that, Mike. Well, that looks like it for our time. So just want to remind everybody that watch out for a follow-up email including a link to this webinar recording and the presentation. We had a lot of questions coming in about if this presentation is going to be available. The email will also include a link to the PDH certificate that you can print out. Please visit Cummins PowerSuite, or excuse me, powersuite.cummins.com for the actual webinar recording, presentation, and any questions that we got to or didn't get to. We're going to be publishing frequently asked questions, and then there's an archive to other presentations in there as well. Also, other Cummins continuing education programs and a sizing and spec development tool. So again, we thank you. If you have any questions, please feel free to contact Mohammed Golem. You see his contact details there. And as always, we thank you for participating, and we look forward to seeing you at the next Cummins webinar series. Thank you, everyone.